This is Module 2, Week 3. In this lecture, we will discuss how we can assist students in preparing for NAPLAN-style questions through best practice pedagogies. Although we may not agree with aspects of national testing, there are good reasons for us to use the test and the data it generates to assist us in planning for teaching and learning. There are a few research papers that promote the use of NAPLAN responses as a way to address student misconceptions. For example, White and Anderson write about the sources of student errors and explore how to address these. To illustrate their point, they use the question you see here, taken from the 2008 Year 7 Non-Calculator Numeracy NAPLAN test, a question that most likely also appeared in the Year 5 test for that year. Only 28% of students in Year 7 answered this question correctly. This is due to the common fraction misconception that occurs when area is not the feature that students identify within a regional fraction model. The misconception here relates to a misinterpretation of the number of pieces. How would you address this in your classroom? This is a perfect example of why strong pedagogical content knowledge is important in mathematics. Providing students with a range of fraction models rather than a reliance on area models using squares, rectangles or circles is a good place to start. Add to this some good questions that promote reasoning. This will encourage students to justify their responses and address the proficiencies or working mathematically components. White and Anderson claim the contextual nature of many NAPLAN items often leads to claims by teachers that these tests are testing comprehension more than they are testing mathematics. However, we must understand that interpreting mathematical situations in context is what numeracy is all about. It is pointless to pursue repetitive symbolic manipulation exercises as a way to address poor responses to contextual test items. This argument is strengthened in the Martin Westwell video in this week's activities, where Professor Westwell claims that students already do well in the fluency aspect of NAPLAN testing. It's the problem solving that requires attention. Problem solving should be at the heart of mathematics lessons, and this is why it's listed as a proficiency or working mathematically outcome. We must teach using a problem solving approach, and we must teach through problem solving, not for or about problem solving. Of course, with context comes the challenge of language. Words can have multiple meaning within the mathematical domain, and multiple words can mean the same thing. For example, within the mathematics words such as unit, square, cube, and scale have multiple meanings, and the mathematical term is not necessarily the commonly understood one. On the other hand, a range of words can be used to describe one context in mathematics. An example of this is the number of words used to describe the concept of zero, including nil, naught, zero, nothing. Consider how the words subtract, minus, take away, and difference are used to describe the same concept. In NAPLAN testing, the term difference is the most often used of those terms. How do we address the issue of language when it comes to NAPLAN? Newman's error analysis can assist in identifying where students are experiencing difficulty in contextual problem solving. Providing opportunities for students to use a wide range of mathematical language and being explicit about their meanings within mathematical contexts is important. Use word walls in your classrooms and think about getting students to create their own mathematics glossary that they can add to each time they encounter a new mathematical term. Often in NAPLAN tests, words, symbols, and images are used interchangeably. One example is when numeric terms are recorded in words rather than symbols, like 2.5. This requires the ability to not only read the words, but to make a mental connection between the symbolic term and its mathematical meaning. Sometimes in tests, numeric symbols are mixed, such as 4 times and 4 more. Students may also have problems interpreting graphics in word questions. Deisman and Lowry describe 3 broad types of graphics in mathematical tasks: context, pictorial, and information graphics. Context graphics serve as an illustrative function, as in this sample NAPLAN question, where the bus is simply paralleling the text. There's no important information to help students solve the problem. The second type of graphic, pictorial, depicts a real object or person and can be used in the same way as real-life objects to give essential information about a mathematical situation. In the question illustrated here, we have a graphic of Australian coins. This provides important information that is essential to solving the task. Students need to identify the coins and add them to achieve a total. The third type of graphics are information graphics. These are similar to pictorial graphics as they provide essential information about the mathematical situation. However, information graphics can be quite complex as they use various systems of visual representation to convey mathematical information. The example here requires what Lowry and Diesman describe as retinal list language. To read about the various other systems of visual representation, go to page 1472 of the Diesman and Lowry paper in this week's list. You will also find some very useful information regarding ways we can support the development of spatial thinking, a skill that is required in a significant number of NAPLAN questions each year. The final challenge I'm going to talk about today is that of contexts within NAPLAN questions that may be unfamiliar to some children. These could be terms used in games involving dice or coins, or the daily application of mathematics in life, such as timetables, recipes, or keeping time. When teaching mathematics, we should include opportunities to familiarise students with dice, coins, spinners, money, maps, recipes, calendars, and clocks. Sounds engaging, doesn't it? Common themes from past NAPLAN questions include shopping and costs, travelling and maps, distances and directions, lengths and perimeters of land, shapes and patterns, food, sport and game scores, clocks, calendars and graphs. It's important that we are proactive and thoughtful in the way we prepare students for NAPLAN. We're not teaching to the test, but we should be giving them the skills to be numerate. What I have discussed in this lecture is simply good mathematics pedagogy. In this week's drop-in session, we'll take a look at some NAPLAN questions and discuss student misconceptions and ways to provide the skills to address them.